Welcome to the DIY Honda Garage channel. DTC P0223 indicates a high voltage issue in the throttle position TP sensor B circuit for the Honda Civic models from 2011 to 2015. The TP sensor plays a critical role in relaying information about the throttle plate's position to the engine control module, ECM, helping manage air intake for optimal engine performance. In this scenario, a high voltage reading, specifically 4.8 volts or more, at the TP sensor B indicates a potential malfunction that affects the engine's overall functionality. Precautionary measures, such as recording freeze data and resetting the DTC before troubleshooting, are essential for effective diagnostics. This guide outlines systematic troubleshooting steps to identify and rectify the problem linked with DTC P0223, ensuring the vehicle runs smoothly and efficiently. DTC P0223 indicates there is a malfunction in TP sensor B, crucial for monitoring the throttle position. The throttle position sensor is typically integrated into the throttle body assembly, which is located near the intake manifold. This sensor's primary role is to communicate the throttle plate's position to the engine control module, ECM. If the input from this sensor is erroneous, indicated by high voltage readings, the ECM cannot accurately adjust fuel-air mixtures, which can significantly impact engine performance. Effective diagnostics require checking the sensor's voltage output, understanding its data relationships with other components, and ensuring there are no core connections or wire issues leading to erroneous readings. There are several potential causes for DTC P0223. Poor electrical connections are a leading suspect. Corrosion or loose wiring can disrupt the sensor's voltage reading. A faulty throttle body itself can yield incorrect or high voltage signals because the sensor may be damaged. Additionally, the ECM could have outdated software that does not properly interpret the signals it receives from the TPS, leading to false readings. It's critical to assess all connections and components systematically to isolate the root cause of the high voltage reading effectively. Taking each potential cause into account ensures that each part of the system is functioning and communicating appropriately. Typical symptoms of an issue indicated by DTC P0223 include the check engine light activating, as the ECU identifies abnormal readings, indicating a potential fault. Drivers might also notice poor engine performance, such as reduced power or stuttering during acceleration, which occurs when the engine cannot regulate the air-fuel mixture properly. Inconsistent throttle response may also manifest. This is when the vehicle does not respond as expected when the accelerator pedal is pressed. These symptoms reflect the TPS's critical role in engine management and highlight the importance of thorough diagnostic assessment in order to restore proper functionality. The first step in troubleshooting DTC P0223 involves verifying the problem by turning the ignition switch to the on position, labeled as II in Honda vehicles. After this, it is critical to clear any existing DTCs using the Honda Diagnostic System, or HDS. This will reset all error codes, allowing technicians to check real-time data. Next, using the HDS, check the voltage for the TP sensor B, ensuring that it reads approximately 4.8 volts or higher. If the reading meets this criteria, the fault has already manifested, and you should proceed to the next troubleshooting step. If it does not, consider it an intermittent issue, warranting investigation into possible loose connections or wiring issues in the throttle body or ECM. Moving on to the second step, Check for any pending or confirmed DTCs with the HDS. This check is essential as it provides insight into the vehicle's status by identifying other fault codes that may be present. If both DTC P0123 and P0223 are indicated simultaneously, this suggests interconnected issues possibly linked to the throttle position system. In such a case, progress to Step 5, where these issues are addressed collectively. Conversely, if only P0223 appears, continue to Step 3 to narrow down the problem area further. This step helps establish whether the issue is localized or part of a larger problem with the electrical system. In this troubleshooting step, begin by turning the ignition switch to the lock position, labeled as 0, to ensure safety while working on the vehicle's electrical systems. Once secured, disconnect the throttle body 6P connector, which is integral to the TPS operation. Turning the ignition back to on, 2, measure the voltage between the specified test points. Test point 1 is the throttle body 6P connector pin number 4, red, and test point 2 is the body ground. The expected voltage reading should be around 5.0 volts. Successfully obtaining this reading indicates the throttle body is operational. If the reading is unsatisfactory, troubleshooting continues to Step 4 to investigate further. The fourth step requires turning the ignition to lock 0 once again for safety. After this, utilize the HDS to jump the SCS line, ensuring that the diagnostic tool is in a proper state to communicate with the ECM. Disconnect the ECM connector C, specifically the pin for the TH2 wire. It's crucial to perform a continuity test between the two test points specified: ECM connector C number 31, PUR, and throttle body 6P connector number 4, PUR. If continuity is present, it indicates that the TH2 wire is functioning correctly. If continuity fails, repairing an open in the TH2 wire, which runs between the ECM and throttle body, becomes necessary before moving on. This step confirms the integrity of key wiring connections critical to the TPS. The fifth troubleshooting step mirrors the fourth, though the focus shifts to testing the SG3 wire for continuity. Begin once again by turning the ignition to lock, 0, and jumping the SCS line with the HDS. Disconnect the required connectors, the ECM connector C and the throttle body 6P connector. Using the same methodology, check continuity between ECM connector C number 14, gray, and throttle body 6P connector number 3, gray. Should continuity exist, confirm that the SG3 wire is functional. If continuity is not established, repair any open in the SG3 wire between the ECM and throttle body circuitry, ensuring a reliable connection for the throttle system's operations. Following all troubleshooting steps, it's crucial to conduct a final repair verification to ensure repairs were effective. Begin by turning the ignition switch to the lock position to safely reconnect all previously disconnected connectors. After reconnecting, switch the ignition back to the on position, 1, and reset the ECM using the HDS. It's vital to perform the ECM idle learn procedure to allow the engine control unit to adapt to the vehicle's operation accurately. Finally, check for any pending or confirmed DTCs again with the HDS. If DTC P0223 reappears, this may suggest ongoing issues such as loose connections at terminals or require further examination of the ECM. Conclusively, effective retrofitting ensures the vehicle will operate smoothly once more. Preventive maintenance helps minimize the reoccurrence of issues like DTC P0223 by regularly addressing key components and connections in the throttle system. Periodic inspections of electrical connectors can prevent corrosion and loose connections, which are common culprits behind voltage abnormalities. Ensuring that all wiring harnesses are secure and free from wear or damage is essential for maintaining optimal function. Moreover, keeping the ECM software up to date will mitigate misinterpretations of throttle signals, as manufacturers often release updates to enhance functionality and address known issues. Taking these proactive measures significantly reduces the likelihood of future faults and enhances the longevity and reliability of the vehicle's systems. In conclusion, effectively addressing DTC P0223 requires a thorough understanding of the roles played by various sensors within the throttle control system. TP Sensor B's accurate functioning is critical for maintaining optimal engine performance, and high voltage readings indicate that something may be malfunctioning. Regular checks on electrical connections and wire continuity are pivotal in preemptively identifying issues before they escalate. Keeping the ECM software current also plays a significant role in the smooth running of a vehicle, ensuring the engine control unit interprets signals accurately. Ultimately, following these detailed troubleshooting and preventive maintenance steps will facilitate the restoration of vehicle functionality and longevity while preventing future complications. Please like and subscribe to the channel. See you next time.